Heat waves can be a nightmare for grids, but they don't have to be. Over the past few months, record temperatures have hit nearly every region in America: the Northeast, Midwest, South, and even California. When this happens, it can cause huge electricity problems as millions of people get home and crank on the AC, putting huge strains on the grid, especially in the early evening. Let's look at a real situation and what happened to the grid in the PJM territory on June 24th when it was sweltering hot. This area chart shows hourly electricity generation for that day. Nuclear is steady in purple, coal and gas in orange and red, then wind and solar in yellow. As you can see, most of the generation is from slow-moving sources, and around 8 p.m. when it was still 96 degrees out, demand surged past supply. The grid had to fire up emergency gas turbine peaker plants. Some areas like Washington, D.C. saw outages, and energy prices shown in this chart above spiked to $3,700 per megawatt hour, 75 times the average of around $50. And PJM wasn't alone here. Over in Mid-Continent ISO, the pattern repeated almost identically. When the sun set and solar energy tailed off here, the slower moving energy sources couldn't keep up with the demand from the scorching hot day. The grid went into scramble mode and the price per megawatt hour of power got up to $1,700 in the evening. Now let's go over to California, where just a week earlier on a similarly warm day, the grid played a very different tune. Here's the same type of chart. You've got steady sources like nuclear and hydro at the bottom in purple, gas and imports in red, wind in blue, and solar in yellow. But unlike the other territories, this time a green section will appear right when the solar drops off and the demand peaks. Those are batteries. On this day, they ramped up from 0 to 11 gigawatts in under an hour, acting as a shock absorber and meeting this spike in demand instantly. Because of that flexibility, the marginal price in California never went above about $80 per megawatt hour, 1/20th the Mid-Continent ISO peak and 1/40th of PJM's. You see, both California and Texas have invested heavily in batteries. Their regulatory paths are much different, but the result is the same: a more flexible, resilient grid. This chart shows the planned capacity of the 10 largest interconnection grids in the country, with green representing batteries, yellow solar, blue wind, and gray everything else. You can see Texas and California with ERCOT and Cal ISO here with tens of thousands of megawatt hours of batteries on the horizon, while smaller grids in Arizona and the Pacific Northwest are following suit as well. PJM and Mid-Continent ISO, which we talked about prior, are also testing the waters in green here, as flexibility and responsiveness become paramount in every grid. So wherever you are on the journey, be it a power supplier, grid operator, or anywhere in between, FlexGen meets you where you are to build battery systems that work anywhere, anytime, in any temperature.